But first, Lisa Whitby reports on the coolest car around.
They're noisy and dirty, but for anyone who's been behind the wheel or even in the back seat, it's hard to imagine life without cars. There are more than 700 million motors on the road worldwide. Every year, another 55 million roll off the assembly line, adding to the global pollution problem. In the United States, the amount of petrol product burnt each day would fill an Olympic pool 840 times over. And American car use creates 413 million tonnes of carbon dioxide every year. That's a fifth of the world total. Finding a clean, safe and efficient alternative to the gas guzzler is a challenge car makers so far have failed to meet. But now, a solution may have been found, and it's all around us, in the air we breathe. Many attempts have been made to use liquid nitrogen as a power source for motor transport, with limited success. But now researchers at the University of Washington say they've discovered a way of dramatically increasing its energy output.
Liquid nitrogen has a lot of energy in itself, but if I put a little bit of heat in, I can quadruple the amount of energy it puts out.
And this is what Professor Hertzberg's team has come up with, the cryocar, a machine indeed running on liquid nitrogen, which as a gas makes up 78% of the air we breathe. The first model was cobbled together for an old mail truck and a Navy surplus motor, once used to lower a ship's anchor. This is Mark II, and while the homely appearance hasn't changed, the new engine is lighter and more powerful.
Ready to go, huh? Yeah, the engine's in. Let's go ahead and fuel it up.
The car's powered by the pressure built up when supercooled nitrogen is heated by ambient air. In its liquid form, nitrogen is extremely cold, about -200 degrees Celsius. But when it's exposed to room temperature, it boils rapidly, expanding 700 times to form a gas.
How's the pressure building up?
Doing well. A byproduct of this shift from nitrogen's liquid to gaseous state is frost, lots of it, which can freeze a motor, literally. Co-creator Carl Nolan's solution is to control the process by heating the nitrogen gradually. From its insulated fuel tank, liquid nitrogen is pumped to a preheater where it absorbs warmth from the engine exhaust. Then the nitrogen is sent to a heat exchanger where the warming and the expansion is completed. So Carl, what happens after you warm up the gas?
Well, the room temperature nitrogen then passes through a regulator, which allows us to set the pressure we're going to operate the engine at. And thereafter, the engine operates much like a conventional car.
Well, the cryocar handles reasonably well, but you're definitely in no danger of picking up a speeding ticket. The engine runs on about 7 horsepower, and that means the fastest it can go is about 40 kilometres an hour. At the moment, the engine only operates at about 20% capacity. Unfortunately, that's one of the design downsides of the need to avoid that engine-killing frost. But the big selling point for liquid nitrogen is the payoff for the planet.
It's inherently benign. It's chemically inert. Comes from the atmosphere and you release it back. In that process, there's a little cleansing. In the sense you have to remove pollutants from the atmosphere to produce it.
And that explains why the car's creators have dubbed it the smogmobile. Nitrogen is the last component of air to condense when it's refrigerated. So reducing the element to liquid form removes greenhouse gases, acting as a filter to provide more than a breath of fresh air. For now, the idea of a widely available liquid nitrogen automobile has stalled, At the moment, it just doesn't make commercial sense. However, fans of the fuel say if it was mass-produced, it would be more economical than petroleum or electric power.
We are going to have to clean up our air. We're going to have to try to live together better. All we're offering is part of the solution.
But it's a solution that signals a super cool choice on the road to an uncertain motoring future. Thanks. Well, it may be a long way off, but when our supply of fossil fuels starts to dry up, we'll be looking for cheap and clean alternatives. And what could be better than a car that runs on thin air? Well, drive on.